Why are they all yellow, Leon?
This is a particle podcast. WA Science told different. Powered by SciTech.
Please Look Up is recorded at SciTech on Whadjuk Noongar land. Good evening, everybody. My name is Leon.
And I'm Beth.
And welcome to Please Look Up, your monthly deep dive into space news.
And commentary.
Recorded at SciTech on Whadjuk Noongar land.
So, Leon, what's up this month?
The question of the ages, Beth. I love it. This month's night sky is actually pretty good for spotting planets.
Ooh.
Yeah, planets have been sort of coming and going the last few months, but they're kind of all coming out in November, so I'd encourage you to keep your eyes out for them, starting in the evening sky just after sunset.
Yep. Are we looking at the sunset again?
Yes, we are, and we're going to visit our old favourite, the one that's been up there for a while.
Yep, and the one that's going to be up there for a little while longer. Like we said last month, I think it's Venus.
It is Venus.
The good old evening star.
Yep.
Or morning star. But the evening star at this time of year, even though it's not a star, it's a planet.
Absolutely.
Yep.
And so, Venus is there. We've spoken about it before. But the thing I want to draw your attention to with Venus this month is to actually compare it to the background stars.
Oh.
Because right now, just to the sort of left, if you're looking at Venus, facing it, so the south.
So the sun has set in the west.
Yep.
I'm looking at the sun as it goes down, except I'm not looking directly at the sun because that's bad for your eyes.
Yes.
Venus rises.
Venus will sort of already be there.
Venus will already be there.
Yeah, it will sort of appear out of the sky.
Yes.
Because, it's out during the day, but then when the sun sets, you can start to see it.
Yeah, so we're looking at Venus to the west.
Yep. And then ever so slightly to Venus's left, the pattern of
stars. So to the south of Venus.
That's right, yes.
Cool.
Is our old favourite constellation Scorpius. And the reason I'm drawing your attention to it is because what you can do is when you have that sort of memory peg of looking at Venus and looking where Scorpius is, if you go out just, a couple of days in a row or maybe once a week apart, you can actually see noticeably Scorpius moving below the horizon as the month progresses.
Oh, so if you go out at the same time, so it's like if I go out at sunset one week and then at sunset the next week, I'll be able to tell hopefully the difference between where Scorpius was at that time last week to next week.
Yes, that's right.
Cool, because of where it is in relation to Venus.
That's correct, yeah.
Okay.
Now, Venus is also moving, but it still gives you a reference point.
Yeah.
And so, that's what I would encourage you to do. However, the other cool thing and the other reason you should be looking to the west this month is because among Scorpius's stars and underneath Venus, so closer to the horizon, there is another planet, the much more difficult to spot, Mercury.
Ooh.
And so Mercury will be there as well. And it's moving, this is one of those things, it's moving very quickly. It's sort of rising up day by day for the first half of the month and then sort of turns around and goes back down.
Yeah, Mercury's got a little bit of a weird pattern across the sky, doesn't it?
Yes. And that's actually because it's closer to the sun than Earth is.
Yes.
And it moves very, very fast. And so it's not so much changing direction in its orbit so much as it is just changing direction again relative to us.
Yes.
So yes, as it swings around the sun, it's always moving in what it calls the forward motion.
Yes.
But because that forward motion is wrapped in a circle,
yeah,
as it turns the corner of
3D space.
Yeah, it looks like it comes up and goes back down. But Venus, a little bit trickier to spot. You can't go out late. You're not going to see it at like 9, 10 o'clock at night.
Right.
You've got to be out in between that sort of hour and a half after the sun has gone, but before Mercury is also set.
Okay, so that's just to spot Mercury. Venus will be up all night?
Venus will be up a lot later.
Okay.
Again, probably at about 9:30.
Awesome.
But Mercury's a bit not as bright and sets earlier, but they are both there in the western sky after sunset all month.
Is there not also, because of where Mercury and Venus are and Scorpius, isn't there a fun little lineup happening this month at some point as well?
Oh, there is too, actually. If I remember correctly, it's on the 4th of November.
Okay.
You will see Mercury near the horizon. Mm-hmm. Then if you look a little bit higher up, you'll see a red star called Antares, the heart of the Scorpion. And above that, you'll see the new waxing crescent moon. Just barely there, but you'll see it. And then above that, you'll see Venus. And they're all within, a handspan of each other. Now, of course, if you don't get out on the 4th, the moon will move fast.
Yeah.
The moon will, on the 5th, it'll be in a different spot. But Mercury and Venus and Antares, even though they are moving and you're going to have to catch them this month, if you're out by a day or two, it's not going to be the end of the world.
Yeah.
Just on the 4th is when the moon is there as well.
Yeah. And I think it's quite poetic because you can see, just looking at the same part of the sky, a star, a moon, and a planet.
Yeah. Oh, it is
quite nice.
It is quite nice.
I think that's quite nice.
Yeah. Oh, beautiful. 2 planets.
2 planets.
Then what you can do is you can turn around And
Okay, so I've watched the sunset in the west. This is all in the west, so now I'm turning around and looking east.
yes, turn around looking
Okay.
east, and Jupiter will be rising not long after sunset.
Oh.
So next month in December is actually going to be slightly better, but you can still warm up
Yes.
in November.
We could practice turning 180 degrees
That's
after
right.
watching the sunset.
That's correct. Yes, it's a very important skill, and so yeah, Jupiter will be rising. In fact, you're probably best waiting, an hour for to really get above the horizon, and it'll be up pretty much most of the night.
Oh, awesome.
And yes, this very, very bright, almost whitish object in the sky, in the evening sky.
Because, well, it's now in the position this month that Saturn was, right? Where it's basically opposite the sun.
Almost. Yeah,
Almost
that's in
opposite the
early
sun.
December. Yeah,
Okay,
opposition
okay.
as we call it.
Yes.
And so yeah, Earth is moving faster, and it's sneaking in between Jupiter and the Sun. It hasn't
Yeah.
quite got there yet. It'll get there in the early December.
Right.
But yeah, that doesn't mean that we can't look at Jupiter now. It just
Yeah.
means that now's our time to practice looking at Jupiter for when
Yeah.
it's in opposition in December.
Yeah, and also if we don't want to super rush our editing team for December, we can warn you about it now.
Yes, that's right. So yes, we're practicing looking at Jupiter there as well. And then if you're up really, really early or really, really late, the Mars is still there in the morning. It's playing peekaboo at the moment. It's just
Is this still in the eastern part of the sky?
yes, that is in the
Okay.
eastern part of the sky. It's sort of moving to the northeast now.
Okay.
To be fair, it's not the best time of year to look at it. But if you're out really, really early or really, really late, 3-4 o'clock in the morning, looking to the northeast, you will see Mars in its kind of red spot there.
Awesome.
But there'll be better times soon. So
Yeah.
don't stay up too late if you don't want to. And then the other real cool thing you can see this month, if you're keen, is there is a meteor shower called the Leonids meteor shower.
Now, Leonids, so meteor showers, they get their names from the constellation from which they appear to originate.
Yes.
So Leonids, we're going to be looking at Leo.
That's correct. Now the thing with Leo,
Not
the
Leon.
constellation. No, not me. I'm not a constellation. I am
Yet.
named after the same namesake as the constellation, but not for
Lion.
any astrological reasons. Yeah, that's right. That's what it means. But yes, if you're particularly savvy with your knowledge of the constellations, you'll know that Leo is up in the morning hours.
Yes.
And so the best time to see the Leonids meteor shower is before sunrise, and specifically on about the 17th, 18th, 19th of November is when it kind of peaks.
Yes.
Now you can go a week either side or whatever, but the sort of peak of the shower expected is about the morning of the 18th of November.
So I have read that the Leonids are historically, like way historically, one of the most active meteor showers just because of how it's basically Earth colliding with the debris head on. And I think that the peak was recorded like hundreds of years ago, but like 100,000 meteors in an hour or something ridiculous like that.
Yes, that's right. I believe that was 1833, so it was a while ago. But, however, it also has shown sporadic peaks like that as well.
Yeah.
Probably never quite that high, but, 10,000, 40,000 in an hour.
Yeah.
You can roughly predict when that's going to happen, and unfortunately that's not going to be this year.
Oh.
It was actually kind of predicted to be a year or two ago.
Okay.
I don't think it ended up happening. But, yeah, it's because meteor showers, as we sort of covered before, is when Earth plows through a dust cloud in
Yeah.
space.
And it's the meteors, it's not shooting stars, it's not stars moving, it's those particles of dust burning up in our atmosphere.
Yeah, that's right. They compress the air, and, you get this sort of plasma around them. And
Meteor versus meteorite? I think
Oh, okay.
this is the one that trips me up all the time, which is why I want to double check.
I'll give you the answer. The
Mete-
definition is
mete-
semantics.
Yeah. Meteors are in space.
Mm-hmm.
The thing, once it's hit the surface of the planet, is a meteorite.
Almost. Well, actually, no, that one is correct. It's
Okay.
the other way around.
Okay.
A meteoroid
Oh.
is the bit.
That wasn't even one of my options.
Yeah. So the meteoroid is in space.
Okay.
And as that meteoroid impacts Earth's atmosphere and you see it streaking across the sky,
Yeah.
that bright thing is the meteor.
Yes.
And then if the meteoroid survives being a meteor to impact the ground,
Right.
that's the meteorite.
Okay. So I was right, I just missed the meteoroid.
Yeah.
Meteoroid?
Yes. Yeah. So it's three
So
different
many
names.
vowels. There's so many vowels involved.
3 different names for the same piece of dust, depending on where it is and what it's doing.
Okay. Is it the same on other planets?
Yes. Yeah, why not? We've found meteorites on Mars. Some of the rovers on Mars have found meteorites sitting on the surface.
Okay.
So, yeah, I haven't seen any indication that they're called anything different.
Okay, cool.
Yep.
Just checking, because I wasn't sure if it was, if meteorite was Earth-specific.
Oh, gotcha. Yeah, no, it is.
It's just when it impacts the surface of the planet.
Then it's, yes, meteorite. That's
Meteorite.
Yeah.
Okay, cool. Thank you. I just thought I'd clarify
you could say
because
it's,
those.
universal.
Oh no! Well, you could not, Leon.
But the bit that's interesting, so yeah, the cloud of dust that Earth is ploughing through to make the Leonids it's not very evenly spread out. It's kind of lumpy. So every now and then astronomers can predict when there's going to be a huge abundance of extra chunky, so to speak, and that's when you get those big meteor storms, as they're called. And as I say, they can roughly predict when those are going to happen, and it's not predicted this year. However, if you are going to go out and check out the Leonids meteor shower before sunrise, you might expect to see a meteor maybe every 5 to 10 minutes.
That's not bad.
Yeah, it's not bad.
So if we're looking for Leo as well,
Yeah.
the thing that I always like to use, and I think we have spoken about this before, but not for a while,
Yes.
is Leo is an upside down question mark,
It is.
which in the UK I would use the Big Dipper or the Plough or Ursa Major to help me find. But we can't see the Plough. We can't see Ursa Major from down here. So, yeah, you just have to look for that weird upside down question mark, and that's
In the northeast.
in the northeast. But I think the Leonids actually seem to originate from basically within the circle of the question mark as well.
Yes, they do. That's right.
So that specific part of Leo. So it's a fairly, once you've found it, and again, you could use everyone's favourite companion app.
Did someone say Stellarium?
Still not sponsored, because they don't need to, because they're great and free. Go use Stellarium. But yeah, once you found that section of sky, it hopefully most of the meteors will be coming from that area.
Yes, that's right. So that's what you're looking for, that upside down question mark. And if you're lucky, you might see some.
Yeah.
Constellation of the month.
Constellation of the month.
Constellation of the month. That's my new jingle. It changes every month.
Love it.
So yeah, constellation of the month this month is a mountain,
Yes,
which is weird.
I know. There's a mountain in the sky.
Yeah. So the mountain is called Mensa.
Yes.
And I've done a little bit of research on Mensa.
We'll just skip straight to the point. Mensa has got nothing to do with the sort of intellectual organisation.
No, nothing at all. It means table in Latin.
Ah, there you go. Good.
Yeah, yeah.
But I thought it's a mountain.
It's a mountain, which is weird because it's the only mountain.
Okay, keep going.
So basically, we thought it would be quite poetic to have moved from Taurus, which is one of the oldest constellations that we have records of, last month.
So that's the constellation of the month in October.
Yes, to Mensa, which is actually a relatively new constellation this month. So it was named in the 18th century.
That is very new.
Yeah. In space terms, that's yesterday. So it was named by Nicolas Louis de Lasalle.
No, I don't know.
Je ne parlais pas de français. But he originally named it Mons Mensae because his observatory was very near Table Mountain.
Table Mountain, there you
in
go.
South Africa. And it's actually the only constellation that's named after a geographical feature on Earth.
Oh, is that right?
Yes.
Okay, so there's monsters and birds and boats and all sorts of things up there.
Yeah, and scientific equipment.
Yeah, of course.
Yeah.
But this is the only geographical feature.
Yes. I mean, there's potentially some argument that, with Aquarius, I think, pouring water, is the water a river or is it? No, because it's pouring out of a cup.
No, I'm sold.
Yeah.
It's a mountain. So what am I looking for when I'm looking for Mensa? What does it look like?
Not much.
Okay.
Yeah,
Where is it?
So you're going to need the help of our friendly companion app. Mensa is in the south, and it's actually one of the most southerly constellations. You can actually only see it if you are south of 5 degrees north. So you can only just see it from over the equator, and that's literally it's right on the horizon.
Right.
And you're looking for a line.
It's one of those line constellations.
Yeah, it's a line.
Is it?
It's just a line.
Yeah. So it's like 2 stars with a line drawn between
It's just
them.
2 stars with a line drawn between them. But something that you can use to help find it are some clouds. So, not real clouds, which is one of the things that frustrates me about naming things in space. So there. First, let me take you to Table Mountain.
Okay.
In South Africa.
All right, so I'm in South Africa.
You're in South Africa.
Yep.
Table Mountain, in the shadow of the mountain.
By the way, if you're not familiar with Table Mountain, it's like someone took a mountain and then cut it in half horizontally and just threw away the top half.
Yeah, it's flat.
It's flat.
It's a flat mountain.
A plateau.
It is a plateau. Yeah. So Table Mountain is often obscured in cloud. So
Right.
it does kind of look like the top of the mountain has disappeared up into the cloud. It hasn't. It's just flat. But the top of that mountain, like, despite being flat, it is still very tall. So there are often clouds sort of touching the top of Table Mountain. So the top of the mountain is sometimes obscured in cloud,
Right.
and so is the mountain in space.
Oh, I know where this is going.
Yeah.
You're talking about
We're talking about the large and small Magellanic
Magellanic
Clouds.
Clouds.
Yeah. They are above the Table Mountain in space. And actually, the Magellanic Clouds, which are not clouds, are sometimes known as Cape Clouds because of
because
because of
Mountain in Cape Town.
Table Mountain on the Cape of Africa.
Right.
Yeah,
Okay, it's all connected, man.
it's all connected, man, but they're still not clouds.
They're still not clouds.
No.
Right, so what are we talking about? The large and small Magellanic Clouds. Now, if I remember correctly, Mensa has part of the large Magellanic Cloud nearby, is that right?
Yes, so it's a little bit of a weird one because the Large Magellanic Cloud is kind of between two constellations because it looks like a big smudge in the sky. If you have a properly dark sky, I genuinely think it looks like a lobster.
Right.
It is kind of lobster shaped.
Okay.
The Large Magellanic Cloud. It's not a cloud. We still haven't told you what it is. It is a dwarf galaxy.
Yep.
So like the Milky Way looks like a big smudge across the sky, it's like a smaller, slightly less bright Milky Way. It's actually sort of, at this time of year, if you've found the Milky Way, it's probably quite low on the horizon. If you're looking south, your Large Magellanic Cloud is going to be off to the left of the Milky Way. And then the Small Magellanic Cloud is another smudge. It's just an even smaller smudge. Doesn't look like a lobster, just looks like a smudge. Slightly further up in the sky.
Further up, yep. All right, so we're painting a picture.
Yes.
So first things first, worth repeating, this only works in a dark sky.
Yeah.
Like you can't see this from the middle of the city or anything
No.
like that.
And Mensa, even in a dark sky, is not a very obvious constellation, which is probably why it's one of the newer recorded
very
ones,
faint
because
one. Gotcha.
it's very faint. So it is best seen with the assistance of a telescope.
Of a telescope around
Yeah.
that. Yep. Okay, so we're going outside in a dark sky. Maybe we're out camping or something.
Yeah.
Looking as basically directly south.
Yeah.
And somewhere up there, holding up my app phone, I can see Mensa as these two very minuscule stars.
Yes.
But then what's really interesting is the smudge that's off to the left.
Yes.
This large Magellanic Cloud.
Yes.
And then the small Magellanic Cloud that's kind of further up in the sky.
Yeah.
Gotcha.
Yeah.
And so you said they're dwarf galaxies.
Yes.
Would you care to explain that a little bit more?
So they are collections, like our galaxy, of thousands of stars, but a lot smaller.
Right.
So they, the stars in that galaxy are clearly being held together around a gravitational point. But the dwarf galaxies basically sort of orbit ours.
Yep.
They sort of follow our Milky Way galaxy around the universe. I always like to say, like an annoying younger sibling. Just sort of like, oh, can I come too? So they are sort of partly at the whim of our galaxy's gravity.
Yep.
But it's just really cool that we can look up into space into another galaxy.
See another
Yeah,
galaxy.
yeah. I mean, I know we can see, particularly in the northern hemisphere, it's a little easier to see Andromeda, who is our nearest galactic neighbour of full size, I would say.
Yeah.
But yeah, the Large and Small Magellanic Clouds are actually the nearest galaxy, inverted commas.
Yeah.
to
dwarf
us.
galaxy is still a galaxy?
Exactly. Oh, but then is a dwarf planet a planet?
Yeah,
Oh no, not that cuttlefish
Shut up,
again.
shut up.
But yes, so they are just little galaxies.
Right. And then, yeah, as we kind of mentioned, the Large Magellanic Cloud is partially in Mensa. It spills over in between two different constellations.
Yes, so we've sort of slipped some we've slipped some other information into this constellation of the month. It's kind of
That's fine.
It's kind of technically in a different constellation, but it is in the Large Magellanic Cloud, which is sort of in Mensa. So I think you were going to tell us about a pretty cool nebula.
Well, yeah, you mentioned there's a mountain in the sky. There's
Yes.
also a spider in the sky. So, no, I remember I was out at a park once and someone was just there with their telescope and they said, have a look at this. And they were pointing at the Tarantula Nebula, which is a nebula, that famous word that we've often discussed on this podcast. But yes, in this case, the Tarantula Nebula is a star-forming region inside the Large Magellanic Cloud.
So when we talk about something being in a constellation, we're talking about the map of space formed by the constellations.
Yeah.
So the Large Magellanic Cloud sort of spans across one of those dividing lines.
Yeah.
So the Large Magellanic Cloud is not like in between the stars, like in physical 3D space. It's just on the map of our sky.
yeah,
It's
on the map
in
of
the
the sky.
constellation of Mensa.
Yeah.
But the Tarantula Nebula is actually
in the neighbouring constellation of Dorado.
It's in the neighbouring constellation of Dorado.
Yeah.
But is that nebula in the Magellanic Cloud?
Yes.
Like it is
I see what
in
you
that
mean, yes.
dwarf galaxy.
Yeah, it's not in the Milky Way that happens to be on the line of sight to
Yes.
the Magellanic Cloud. No, it's in the Magellanic Cloud. So it's outside of our galaxy.
So 3D space.
Yep, 3D space. It's 160,000 light years away.
Yeah.
Which is outside of our galaxy.
Yeah.
Yep. 100%.
Whereas the stars in
the stars in Mensa
Mensa are in
are
our
in
galaxy.
Yeah.
Cool.
Yeah.
Yeah, sorry. It's just 2D, 3D space thing.
Yeah, this whole line of sight thing. Yeah, definitely. But yeah, no, the Tarantula Nebula inside the Large Magellanic Cloud is the most prolific star-forming region in our nearby universe.
Whoa.
So, quick recap. Stars form when a cloud of gas, mostly hydrogen, kind of collapses under its own weight, and then it kind of fragments into little bundles, and those little bundles eventually form individual stars. But then what happens is, as the stars ignite, there's still this residual pool of hydrogen and gas that they're still surrounded by, and as these stars start to shine, they burn away pockets of that gas, and so you get this sort of region of very, very densely packed new stars surrounded by this huge wispy region of very, very hot hydrogen. And the Tarantula Nebula in the Large Magellanic Cloud is probably the biggest and best version of that. And it's visible in the Large Magellanic Cloud. And yeah, I just happened to be walking past someone at the park who said, do you want to see the Tarantula Nebula? I'm like, yes, please.
Yeah.
And
Did they know it was just some random... Did you then tell them that you are a planetarium coordinator? Or did you just...
No, I kept it to myself. Yeah, it was a nice moment. But to give some context for this, so in the coming podcast, as Orion becomes more visible in the sky, Orion is a summer constellation.
Yes.
We'll no doubt talk about the Orion Nebula.
Yes.
And the Orion Nebula is, very famous. It's about 1,000 light years away, and it's
So that's in our...
it's inside our galaxy,
Yep.
inside the Milky Way. And if you hold up your pinky at arm's length, you can cover the Orion Nebula with the nail on your pinky. So in real life, it's very big, but it
Yeah.
also, relatively speaking, from 1,000 light years away, it looks quite small. If you put the Tarantula Nebula where the Orion Nebula is, like if you
Yes.
put it inside our galaxy, it would cover about half the sky.
Whoa.
That's how big it is.
That is a big star-forming region.
It is enormous, and so it's prodigious. It's really, really. If you happen to have a telescope and you somehow haven't looked at it before, would recommend.
Oh, amazing. So I think that's pretty much it for what's going on up in the night sky with our constellation of the month.
Yep.
I think that leads us on to something quite exciting. I think that leads us on to spaceflight focus.
Spaceflight focus.
Spaceflight focus. So the first thing that was on the research list this month was spaceflight focus. Starship. Yeah. So I went in. Starship. The members of Starship were actually some of the last members who existed from Jefferson Starship. And there was this whole big legal debate from Jefferson Starship, which was also originally formed by the members of the band Jefferson Aeroplane.
Right.
So it's like the last remaining members of Jefferson Aeroplane then formed Jefferson Starship, and there was this whole big legal debate, and they split up into two bands, and it was originally called Starship Jefferson, but then they decided that they weren't allowed to use the name Jefferson,
Right.
and then we had Starship, who made the song, "We Built This City on Rock and Roll." So yes, that's my research that I've done on Starship.
Yeah. That's fantastic, Beth. Thank you. You've been looking at the wrong starship.
What?
That was good. You had me fooled for a second there. Where on earth is this going? Was that true?
Yeah.
Everything you just said?
Yeah, I genuinely researched because I thought Starship, I swear that's a band. And then I was like, oh, wait, I didn't know that Starship came from Jefferson Aeroplane.
Wow, there you go.
They did. Genuinely, eventually, that's where that
You
goes.
sign up for the space news and you get everything.
A little bit of music in there as well.
Cram full of facts. In case you somehow missed it, obviously we're talking about the SpaceX Starship, which has been, this is a few weeks ago now as of this recording, so we won't cover it in huge amount of detail, but we can't just pretend it didn't happen.
It was so cool.
It was amazing, mainly because of the catch. Yes, Beth is doing crab hands off camera. So for those of you who have been under a rock, or if you just missed it, so the general gist is Starship, big old rocket, comes in two halves. The whole rocket lifts off. The first half keeps going
Does
into
the rocket
space.
thing.
Yep. Sorry, the second half I should say. Let's try that again. The whole thing takes off. The top half keeps going into space, and the bottom
rocket
half,
bit.
the bottom half, once it runs out of fuel, is supposed to come back, and eventually they're going to try and snatch it out of midair and put it back on the ground and refuel it.
So in like an old school conventional rocket, that's the part that would just fall in the sea.
Yes, in an old school conventional rocket, yes, that's right. It's one single use only.
Yep.
SpaceX have gotten famous for using their other rocket, the Falcon 9,
Yep.
where they've managed to land that bottom half of the rocket.
Yes.
But then for Starship, what they've been trying to do, and they finally succeeded, is try and fly it back to the launch pad and snatch it out of midair with what is essentially a giant pair of chopsticks.
A little crab hands.
Yeah, little crab hands is basically what it looks like. Yeah, if you make a crab hand in your hand, with your thumb
Pinch.
and fingers, yeah, you know what I mean. Do a Zoidberg.
It's carcinogenesis.
Oh, is that where everything becomes a crab?
Everything will eventually become crab,
Yeah.
including rocket ship
Including
catch
rocket
mechanisms.
ships. Sure, why not?
I was having a great day on my research day yesterday.
Yeah. So this is exciting because this was test flight number 5. So test flight number 1, it went wrong right from the start.
That's what we test flight for.
Yeah, it didn't even separate. Test flight 2, it separated, but exploded. This is the bottom half, exploded almost straight away.
Not meant to do that, meant to come back.
Yeah, that's right. Test flight 3 and 4, what they did was soft landings, where they flew it back, but they didn't go right back to the landing pad. They went just offshore because the launch pad is actually right on the beach.
Yes.
And so they landed a couple of kilometres out, landed, quote unquote, in the ocean.
Crashed in the ocean.
Yeah, just to prove that they could.
Yeah.
But this one was the first time where they were trying to attempt to snatch it out of midair. And the reason this is so amazing is because if something goes wrong, there's no back out for this. They're going to destroy their entire facility because Starship doesn't actually have landing legs. It can't land.
It has to be caught by the little crab hand.
It has to be caught by the crab hands, yeah. And that's to save on mass. So Starship already weighs 150 tons
because
fuel.
this is their big rocket.
Big rocket, yeah. And there are fully fueled rockets that weigh less than this thing does empty.
Yeah.
And so, you're going to need some really strong landing legs, probably 10, 20 tons worth of steel landing legs to hold up the rest of the ship.
Which means you then need more fuel.
More fuel, and it's
and then it's a bigger ship, and then you need
and it just runs away. And so the thing has been designed from the start to have no landing legs, so it has to be caught from midair, and they finally succeeded in doing that.
It's so cool.
But and it's just you lose perspective because you see those amazing videos. They're beautiful, and you see this thing coming down and it catches it. And you got to remember it's the size of a 19-story building, and they're catching it out of midair. So go outside.
And also, there's not a person driving it.
No,
either.
No people on board. No people
board.
flying it.
No,
no stick. Nothing.
Yeah.
It's all just computers. One of the things that I think is really cool is worth going back to the video and watch what happens. When Starship comes back to the pad, the tower, Mechazilla as it's called, because of course it is.
Ridiculous name.
It comes down and it almost looks like it's missed the pad because it's coming in vertically, and then you can see the tower and you can see the rocket, and they're both straight up, and Starship's like, it's in the wrong spot, and then right at the last second it does a shimmy to the side. And the reason for that is just in case something goes wrong at the very last second, and it runs out of fuel and it falls to the ground. It's going to miss the tower.
At least it's not crashed into the tower and broken their whole launch setup.
That's right. So I encourage you to go back and rewatch the launch just that one more time if you haven't already watched it 400 or 500 times like I have, and watch that catch and just watch that little shimmy it does right at the very last second. And it's pretty funny because it's on fire because they're venting fuel, and it obviously it hasn't gone 100% perfectly, but the fact that they caught the thing out of midair on the first try
is incredible.
Is incredible. Eventually, the plan eventually one day is once they get it perfect, I'll just put it straight back on the launch pad. Fuel
So
up
it won't do the little wheel.
Oh, no, as in so at the moment, this current booster that they've caught is probably never going to fly again.
Okay.
Let's say it was on fire, it's probably heavily damaged. But
Okay, right.
Once they perfect this, we're talking 10, 20 years.
Yeah.
Yeah, catch
It
out
will
of
be
the
the
air.
norm.
Yeah, it'll be the norm. It'll be the norm. Catch it out of the air, put it on the launch pad, put another Starship on top of it, send it back off to space that afternoon. That
would be very cool.
That's their target. Whether they'll get there, who knows? But
Yeah. But Starship is not the only spaceflight exciting thing that's happened this month.
No.
We've got a treat.
Yes, we do.
It's a 2-ship month.
A 2-ship month, yeah.
So again, I did some research because the next space thing we're looking at is Euclid.
Yes, Euclid.
Yes. So again, this time I didn't mess up. I did have a look at the other Euclid, as in the ancient mathematician.
Yes, I'm familiar with Euclid.
Yes. Well, and you should be, because you know me, I like my where do names come from. Euclid literally means well famous.
Well famous what?
No, he's just well famous.
Euclid means well famous.
It means well famous. Well, so the U part means well, and the clid part comes from Greek to mean fame. So Euclid is
Really?
literally well
famous.
famous. It's well
geez.
famous.
So that immediately makes me wonder, because we're always taught Euclid was one of the greatest mathematicians who ever lived. If his name is well famous, do you think maybe it's more conceivable that the body of knowledge has become called Euclid, and that Euclid was Euclid real? I don't know.
I think that we're not sure necessarily if
I should
Euclid
know
was
this.
one specific person.
Yeah, whether it was a school
or
like Pythagoras.
Well, or whether it was that kind of thing. But
Or maybe well famous means well famous now because of Euclid.
Oh,
Because that stuff back, because we all know Euclid. Like, even if you don't know Euclid, you know Euclid.
you've
Euclidean
probably
geometry,
Euclidean geometry,
straight lines,
3D space.
parallel lines never meet.
Yeah.
Two lines that aren't parallel will only cross in one point. Things like that.
Yeah. So I don't know.
Means well famous.
But it does mean well famous, which I just thought was quite funny.
Wow. There
But
you
the
go.
spaceship,
The spaceship.
which is also going to be well famous.
Yeah. So the reason it's in the news this month. So what we're talking about, there is a European Space Agency spacecraft. It's actually a telescope called Euclid, and it's named after this ancient Greek mathematician. And it's a little bit less well known than like Hubble and James Webb and things like that, because it's what's called a survey telescope. So you don't ask nicely for time to use Euclid to point it at what you want, like you can with Hubble or James Webb.
Right.
You can write a letter to the director of NASA and say, "Can I use James Webb?" and point it at this, and they'll go yes or no. Euclid is already automated; it's doing its thing, and so
But it's doing a really cool thing.
it's doing a really cool thing. Its job is to find all the galaxies, just as many galaxies as it can. So it's equipped with a very large mirror, and it just scans the sky in a very systematic way, and it's eventually going to map 1/3 of the whole sky, which is a huge amount, to a depth of 10 billion light years, which is a huge percentage of the universe. And it's looking for galaxies, for everything it finds, every galaxy, puts it into a catalogue, and it's going to try and map the distribution of galaxies over huge cosmic times and distances.
Now, this is one of those telescopes that makes images where you're like, oh, what a pretty map of the stars. And you're like, not stars, galaxies.
Yes, that's right. Spoilers for what we might be looking at later.
Oh, no, sorry.
It's all right. But yeah, the reason Euclid's in the focus this month is because the European Space Agency has just published part of Euclid's data.
Oh,
and
that's very kind of them.
Yeah, and it's revealed a map of 1% of the sky. So look at the sky and imagine 1% of it.
That's not much.
It's not much. So, and I mean, really look around the room and just imagine 1%. And it's released its data on 1% of the sky, and it found 14 million galaxies in that little speck of the sky.
14 million galaxies.
Yes, like not million stars.
How many stars are in our galaxy?
So in the Milky Way galaxy, we think there's at least 100 billion stars, and we're just one galaxy. And so
we've just found
14
million
yes,
galaxies
in this little one speck
in
of the sky.
1% of the sky.
Yes. So wrap that up around the whole sky, and yeah, it's just nuts.
Mind blowing.
And so, yeah, I strongly encourage you to go and just plug in European Space Agency Euclid I don't know, 1% sky map or something.
Yeah.
And there's a really good video of the European Space Agency that they put together that sort of breaks down this patch of the sky, and they keep zooming and they just keep zooming and they just keep zooming, and the galaxies, they come out of their specks and then smudges and then spiral structures and everything.
Oh, wow.
And so, yeah, that's really cool. Now, the reason I should mention, by the way, the reason they're doing this is one of the big unknowns is the behavior of, you've probably heard of them, dark matter and dark energy. Ooh, yeah. Now, if you want to know what they are, I wish I could tell you, but nobody knows.
Yep.
So
That's why I haven't brought it up in Deep Sky Dictionary ever, because I'm like, what does this mean? It's a mystery.
Well, yeah, what they represent is deviations from expected behavior of gravity. However, to study them, you don't really notice them until you look at things as big as galaxies.
Yeah.
And so the plan is you look at the galaxies that are 10 billion light years away, really long, really far away, really long way back in time, and then you look at the galaxies that are 5 billion light years away, and then you look at the galaxies that are 1 billion light years away,
right?
And then you compare: are they the same? Are they different? Are they behaving differently? Are they moving differently? If so, why? And if there's anything we can't explain with our current sort of models, is that different behavior caused by dark matter and dark energy? So even though you don't really see the dark matter or the dark energy, you see the effect of the
resultant
dark matter,
behavior.
Yeah, on the galaxies, because you can see the galaxies.
Yes.
And they are influenced by the dark matter and the dark energy. But you can't do that without the galaxies. So that's why we need more galaxy data. We need the mother of all galaxy data sets.
Right.
So
which is what Euclid is doing.
Yeah, we're getting about 100 gigabytes of data per day back from Euclid.
That's pretty good.
And that's going to keep going for the next 5 years.
Oh, that's awesome.
Yeah, so this is just the start of it.
Oh, that's incredible. Now, when I was looking at Euclid, I found out that it's in the same sort of part of space as a couple of other things. It's in the same part of space as Gaia and old Webby.
Oh, Jimmy Webb.
Jimmy Webby Spacey Telescopy.
Yes.
The James Webb Space Telescope. And I found this sentence, which is, they all orbit L2, which is the Sun-Earth second Lagrange point.
Yep.
What?
What do you mean you don't understand Lagrange points?
I don't understand Lagrange points, Leo. What's a Lagrange point?
Yeah, Lagrange points are a subtlety. They're intuitive, but they get pretty subtle pretty quickly. They're think about this. Do you remember last month where we were talking about how Pluto and its largest moon, Charon, don't so much... It's not so much like the moon orbits Pluto, so much as they orbit each other.
And there's a point in between them that they're both kind of in orbit around.
Yeah, essentially.
Yeah.
So similar to the idea, imagine you are in between two objects, for example, Pluto and Charon. In one side, you're going to have Pluto pulling on you in one direction, and in the other direction, you're going to have Charon pulling on you.
Yep.
Now, and this can be anything. This could be the sun on one side and the Earth on the other. It could be the Earth on one side and the moon on the other. Just pick two astronomical objects and imagine yourself in between them.
Yep.
Now, depending on how heavy those objects are, somewhere in between those 2 points there is an equilibrium point.
Yes.
Where you're exactly balanced in both directions.
Right. So if I'm between the Earth and the Sun, because the Earth is so much smaller than the Sun, that point is going to be way closer to Earth.
Correct.
Okay.
And that is what we call the first Lagrange point.
Oh.
Yeah, it's a point of gravitational equilibrium where everything just works out.
Okay, that's nice.
Now, the second Lagrange point is on the other side of this thing, and you're like, well, how can there be balance there? But think about this. Earth moves essentially around the sun.
It does.
And imagine you're moving around the sun with the Earth, but you're a little bit further out.
Okay.
Okay, but you still have to go around in 1 year. But because you're further out, you actually have to go slightly faster. And because of that, when you go around a roundabout and you get flung out,
yes,
your tendency to get flung out is going to be bigger. So
yes,
normally if it was just the sun there and you were that far out, you would get flung out. However, there's something else pulling you in.
The Earth is pulling me back in.
The combined gravity of the Earth and the sun makes for another equilibrium point, and that is the second Lagrange point.
Right. So James Webb, Gaia, and Euclid are all
at
L2. But that doesn't mean they're all on top of each other.
No, that's right. In real life, L2 is sort of this region.
Yes.
Yes. It's mathematically...
It's not a point.
No, that's right. Mathematically, it's a point. In real life, it's a region.
Yeah.
And so, they're actually nowhere near each other. They're, within...
Okay.
So, in case you're wondering, it's about 1.5 million kilometres away from Earth in the exact opposite direction from the sun.
Okay. Is there anything in particular that makes that a good spot for a space telescope?
The reason you want to do that is because well, there's many reasons, but the main reason for these telescopes is you're away from the noise of Earth. So Earth has a lot of radio noise, obviously, but also just heat noise and infrared. So James Webb and Euclid both have infrared capabilities.
Right.
So you don't want noisy heat from the Earth getting in the way. But the other main reason is that because it's a point of gravitational stability, you have very little chance of accidentally drifting off into space.
Right.
So
that
it
would
requires,
be bad.
Yeah. So all satellites require what we call station keeping. This is something that they don't really tell you about, but every now and then you have to turn the engines on to make sure you don't drift away.
Right.
And depending on where you are, you need to use different amounts of fuel, things
Okay.
like that.
So the second Lagrange point, because it's got that gravity of Earth helping it stay where it is,
Correct.
we can be more efficient with our occasional bursts of fuel.
That's right. Yeah.
Awesome.
And in fact, side note, funnily enough, when the James Webb Space Telescope launched in 2021, it was expected to last about 5 years, and the biggest problem with that was just the amount of fuel it could carry with it. However, the rocket that launched it got a little bit of extra performance out of it, so that to get to the Lagrange point, Webb didn't have to use as much fuel.
Oh, so we can
and that literally
last
doubled the
longer.
lifetime of the
Oh
the
my
telescope.
goodness, that's awesome.
Yeah, because that's how little fuel, like it's just a couple of 100 kilos extra.
Yeah.
And that gives you
Makes
another
a big
5 to 10
difference.
years. Yeah.
Awesome.
So that's why they're all out there.
Now, when I was looking at all of these space telescopes, I noticed something. And that leads us to a brand new segment.
Ooh, okay.
Yeah. We're trying it out because this leads us to the segment Burning Questions.
Burning questions.
Burning Questions.
Oh, no.
So this is going to start with a question from me, but we're hoping that maybe one day this might develop into if anyone listening has any burning questions.
Oh, yes.
They'll be able to
Send us your questions.
get in touch with us. I think at the moment the best way is probably by commenting on Instagram.
Okay.
Is probably for now.
So our
We're
Instagram is @ParticleWA.
at Particle WA,
Perfect.
where we put up our photos from Space Photo of the Month.
Space Photo
We
of the
can
Month,
put our
yep.
photos up, and then if you've got questions, you can comment on that maybe and
Perfect.
send them in, and we'll give it a go and see if it works. But I have a question for this month.
Okay.
I was looking at- I was
you
look-
look like you're looking at me like you expect me to know the answer.
I was looking at all these space telescopes.
Okay.
Why are they all yellow, Leon?
What?
Why are all of the space things yellow?
Yellow.
Yellow. James Webb, it's got a big yellow bit on it.
Yeah.
Euclid, big yellow bit. Not a space telescope, but Voyager, yellow bits.
Oh.
There's yellow bits on. Why are they all yellow?
Why are they all yellow?
Why are they all yellow, Leon?
They are, aren't they?
They're all yellow. Why are they all yellow?
I do know why, actually.
Why are they all yellow? This is my other thought that we could call this segment "Why are they all yellow?"
Why are they all
But I think
yellow?
it'll only make sense
in
to me.
memorandum of the first question. That's a good question. You know, that's something that I just take so taken for granted that
Yeah.
I hadn't even thought about it. Webb's a bit more complicated.
Okay.
But yeah, so I guess good point. So if you're wondering, go and look up a picture of Voyager 1. Just plug Voyager 1 into Google image search or something
I
like
think
that.
our producer is genuinely doing that right now.
Yeah, and yeah, you'll see the whole thing is covered in what looks like gold foil.
Yeah.
Even the lunar landers that you see on the moon, they look like parts of them are wrapped in gold foil.
11.
Yeah, the eagle.
Yeah, that one.
That one.
The one that landed.
Yeah. And the reason is actually that we'll cut straight to the answer is insulation.
Oh, that's way less exciting than I thought it'd be. I'm sorry.
It's insulation. So space is one of those weird things where it's really hot and really cold at the same time.
Yeah.
And so depending on what you've got there, whether it's electronics or fuel tanks or whatever, it needs to be kept at certain temperatures.
Humans.
Humans, yeah,
They
exactly.
definitely need to be
They
at very
need to be
particular
certain
temperatures.
Yeah. And so depending on what it is, you need to insulate or dump heat from your thing. So some spacecraft actually have heat sinks or radiators. And so most insulation is made up of either a plastic called mylar.
Oh, that's the foil that they make like emergency blankets out of.
Yeah, there
So
you
like
go.
if you've run a marathon, you might get covered in a weird little crinkly foil sheet.
That's right.
But that's silver.
Yes, it's because they take the mylar plastic and then stick onto it aluminium as well.
Okay.
That's one of the things. That's as you just said, more of a silvery color. But then the other common thing is Kapton, and Kapton is it's just yellow. But so then when you stick yellow Kapton onto aluminium foil,
Right.
you get what looks like really shiny gold foil.
Oh, okay.
And yeah, and this stuff is just really, really good. And it just happens to be the reason you use aluminium is because it's very, very reflective in the first place.
Right. So if you're trying to insulate, you want layers, but you also want the literally bouncing heat and light off.
Yes, that's right.
Yeah.
So yeah, you put the aluminium to just bounce off most of the light in the first place, and then you have the layer of plastic so that if any light gets absorbed, plastic's a very terrible conductor.
Yes.
And then you have layers so that you can, in the vacuum of space, it acts like the layers of a vacuum flask.
Okay.
And so the heat shield of the James Webb Space Telescope is actually 5 layers of plastic like that with a large vacuum gap in between.
But you said James Webb was a bit different.
Yes, as well. So the heat shield is this sort of layers of plastic, but Webb does have gold on it too.
Oh.
And it actually is real gold.
Oh, okay. So there is gold involved.
There is gold.
Good.
This is specifically on Webb, on the mirror. If you ever see pictures of the James Webb
Big
Space Telescope.
yellow honeycomb-looking
Big
bit.
honeycomb mirror, yeah. And that's specifically because it's an infrared telescope, and that honeycomb thing, it's the mirror. What it does is it reflects light, and gold, it just happens to be really, really good at reflecting infrared light.
Are those mirrors not 6 meters across?
The whole mirror is, yeah. So there's
So there's 6 meters of gold?
No, good question. No, actually, it's atomically thin gold.
Oh.
Yeah, I did some maths on this ages ago, and it's like, I think it's about 40 atoms thick of gold. So it's less than 100 grams of gold on the entire thing. So the whole thing's like 30 or 40 square meters.
Right. But there's only 40, 50 grams of gold on it.
Yeah.
Okay.
The way they do it is they take the mirror segments, put it in a vacuum chamber, put a tiny piece of gold, suck all the air out, and then heat the gold gently.
Oh, so
and
it just
as
spreads.
the vapor pressure of gold, 2 or 3 atoms evaporate and they stick onto the mirror. And
That's pretty cool.
Yeah, that's how they do it.
Oh, that's really cool.
So that's what. Yeah, Webby is genuinely yellow because of gold.
Okay.
Most of the rest is because of plastic.
Oh, cool. And it's just to help keep them warm or cold.
Yeah, it keeps them warm or cold.
Awesome. Thank you, Leon.
There we go. It's time for me to ask you a question.
Oh.
I think it's time for Deep Sky Dictionary.
Deep Sky Dictionary.
Deep Sky Dictionary.
I am not sure I know
Perihelion.
how to answer
Perihelion.
that.
Perihelion. Why?
Sorry, I'm Australian.
Right. I'm going to call it perihelion because it comes from Helios.
Okay.
So maybe it should be
Perihelion. Yeah, I'm just saying it
Perihelion.
like a bogan.
Okay.
Perihelion.
Perihelion.
Yeah.
Helion. Okay. Perihelion is Greek.
Uh-huh.
It comes from peri, meaning around, and helios, meaning sun.
Mm-hmm.
So the perihelion comes with a partner word,
Okay.
and they're very easy to get mixed up between.
Mm-hmm.
The other one is aphelion.
Yes.
So the perihelion is the point at which an orbiting body is closest to the sun, and the aphelion is the opposite. So the aphelion is the point at which an orbiting body is furthest away from the sun.
Perfect.
Yeah,
That's a pretty sensible definition.
yeah. But they are really easy to get mixed up between, which is why we did it in definitions.
Yeah, it's interesting because the idea, astronomers have taken that idea further.
Oh.
Because, you can talk about planets moving around the sun or even comets and asteroids.
Yes.
They have their perihelion and their aphelion.
That's why it's an orbiting body, not just like a planet, because it's literally anything orbiting. And I think it's any sun, not just our sun.
Yeah, I think so in general. But yeah, that's where the helion comes from.
Yes.
But you can take a planet and have something orbiting that planet.
Yeah,
and
also true.
That's where you get, you might have heard perigee and apogee.
Ah.
And G, of course, being for geo, being Earth.
Of course.
So you'll often hear astronomers talk about the lunar perigee and the lunar apogee.
Okay, and that's just
when the moon is at its
furthest and closest to Earth.
yeah, of closest and furthest, respectively.
Yes.
Peri means close and apo means far. A common one as well is Jupiter for Jove. So you hear about peri-Jove and apogee and things like that. In theory, you can make one for anything, but then of
Can we
course
have a perihelion? If I run around you in circles,
I mean, yeah, that's true. That's what it would be.
the
which is-
aphelion is when I'm furthest away, and the perihelion is when I'm closest.
Sure, I'll take that. It's interesting because aphelion is spelled A-P-H-E-L-E-on, whatever, and it's tempting to read it as aphelion.
Aphelion, yeah,
Yeah, but
because
it is
it's like
aphelion.
helicopter.
Yeah, yeah.
Is people think it's Heliocopter,
Yeah.
but it's actually helico and pter. So pter is the same as the ter in pterodactyl.
Yeah.
So the ter is the flying, and the heli is the helix, the motion of the blades.
That's right. So this is the app for
Away.
far.
Yeah.
Away, and helion for the sun.
Yeah.
But yeah, in general, the modern terminology these days is apsis. If you want to get real fancy, we just say the periapsis and the apoapsis. So, if you've got a spacecraft flying past a moon of Mars,
Right.
orbiting a moon of Mars.
You don't need to come up with a new suffix for every single
that's
thing
right.
you.
It's just the periapsis and the apoapsis.
Fair.
Well, there you go. Thank you for that Deep Sky Dictionary. Actually, that does bring me to an interesting point because there's been talk in the news about a comet lately in the night sky.
Yes.
Comet C/2023A3 Shinshan, I believe.
Yeah.
Atlas.
Atlas.
And it has a perihelion.
Oh.
But if you look at some sites, and they're still updating it, it doesn't have an aphelion.
Oh.
And that is because we think it's on a one-way trip.
Oh, it's
come
not
in from
in
afar.
orbit.
No, and we think it's picked up enough energy from passing by that it's going to get flung out of the solar system. So
Surely that means that it doesn't have a perihelion either, because perihelion refers to an orbiting body.
I think you can still argue that it has a closest point.
Yeah. Even though it's not an orbiting.
It's not a closed orbit,
Okay.
but it's still an orbit. It just happens to be an infinitely long open orbit.
Of course. Trip.
Yep, why not?
Cool. Space photo of the month is a favourite. Not the last one this month, though. We've got a secret second one coming. What's your spaceflight photo? I feel like we alluded to it earlier.
We alluded to it before, and you've probably already seen this, but it completely blew me away when I saw it, so I just wanted to talk about it. So there you go. There's your picture to try and describe.
So what I'm looking at is what looks like a star field. So it is a picture which is just full of points of light. There are some reds, blues, purples, lots of white points of light. Some of them are a little bit more smudgy, which makes me think that this is not a star field, but I have a feeling that this is actually a galaxy field.
Nailed it. Yeah. Yeah, we alluded to it before. This is an image taken by Euclid, our friend and saviour. And
well famous.
Yeah, well famous. And yes, you're right. Those objects we're seeing in this picture are, the overwhelming majority of them are not stars, they are galaxies.
Oh, that's incredible.
And in this picture, there are about 100,000 individual galaxies in this one picture. And that's what we're just holding on our phone in front of us.
Yeah.
And this brings to mind, see, I'm old enough that I remember when in the mid-1990s, there's a picture taken by the Hubble Space Telescope.
Yes.
Called the Hubble Deep Field.
The Hubble Deep Field, yeah.
And if you haven't seen it, go and look it up. It's got about...
Also beautiful.
Yeah, it is amazing. It's got about 3,000 galaxies in it. And it was the first picture of its kind where you just point a telescope into the darkness and see what you can find.
Yeah.
And 3,000 galaxies. And
that was
everybody
revolutionary.
It revolutionised our understanding of cosmology. 3,000. Now we've got 100,000 in one picture.
So exciting.
100,000 galaxies. And remember, each galaxy probably has 100 billion stars. It's just...
There's so much stuff out there.
Yeah, you know that feeling you get sometimes when you look up and you're like, oh, gee, they're all far, far away. And, am I important? What's my place in all of this? And then you look at one of these pictures and you're like, oh, my goodness. There's a lot of stuff out there.
No, I don't get that.
No? Okay.
I know I'm important.
Yeah. See, when you... well, for me, this is quite refreshing because when you work in the planetarium long enough and you look at these huge data sets of galaxies, you get, I call it familiarity blindness.
Yeah,
where you see it so often, sometimes that awe of the first time you see it can
wears
get tempered.
off. Yeah.
But then you see a picture like this and you're like, there it is.
It brings
again.
it back. Yeah, it definitely does. I was fully joking.
I think you're important as well, Beth.
Thanks, Leon. But yeah, it's absolutely incredible. Also, we call it a data set. It's beautiful.
Yes.
Like, it is just genuinely pretty. And I think it's also nice to remember when we are talking about data and that kind of thing. Like, it can feel very dry, especially if you don't have the knowledge and skill that people have worked for years to gain to interpret that data in a way that seems meaningful. But this, I love that it's also just a really pretty picture.
It is, isn't it?
Yeah.
All right, Beth.
I
what
have a
you got
very
for me?
different kind of picture for you.
Okay. Okay, it looks very old, most because the picture is very pixelated. It almost looks like it's taken from a little automatic surveillance camera in the corner. There's three what look like to be men sitting around what looks like to be a mixture between a basin and a dining table.
It does.
If you imagine a bathroom basin sitting on a cylindrical stand, and then at equal angles, 120 degrees around, there's trays sticking out from each side, and it looks like bowls and saucers and things. And there's one gentleman sitting at each of these tables, by the looks of it. I don't really want to necessarily call it a meal because I can't quite tell what's on the trays.
Yeah.
They're all wearing this mud brown T-shirt. One of them, I believe, has a NASA logo on the T-shirt, and it looks, by the way, they're not so much sitting as they look like they're actually just floating in space. And it looks, and it's inside a very small room, so it leads me to suspect they're on some sort of old space station.
They are. So this image was taken on November the 22nd, which is why I've included it this month.
Ooh.
1973.
Oh, I know what this is.
This was the first crew to celebrate Thanksgiving in space.
Ah.
Yeah, so these are the Skylab 4 astronauts from left to right, Gibson, Pogue and Carr eating on Skylab.
Ah.
Yeah, so they it was an 84-day mission, and on their 7th day, Gibson and Pogue did a 6.5-hour spacewalk, which means they missed lunch. And Carr was in the multiple docking adapter and didn't have access to food during that time. So they made up for lunch by having double meal at dinner time instead. But there was no special anything for Thanksgiving. And I know this is a very American-centric, but I thought it was nice to include it in the month that was relevant. And I like thinking about how long it has been that we have had people in space. Like from the 70s. And yeah, this is sort of like a fisheye photo that was taken from like a corner camera, but I think it's still incredible that, this is probably taken on film.
Yeah, probably.
Rather than digitally, and we still have that evidence.
Yeah.
And I like the humanizing, like we had a picture of an astronaut having their birthday in space. And I enjoy the, that human element again, like we talk about they're scientists up there, they're doing their job, but they're also people.
They are
and
people.
they have things like birthdays and holidays and Christmases and everything up there.
Yeah, there you go.
So yeah, this is them eating on Skylab 4.
There you go. I mean, we can't mention Skylab without, of course, mentioning that it's here now.
Yeah.
In Esperance.
Yes, that's very true.
Yeah.
I'm actually going to Esperance next week, and
I
I'm
was there
hoping to go
last month.
sneak into Skylab.
Yeah. So for those of you who don't know, so Skylab was an American space station in the 1970s, and it underwent an uncontrolled re-entry to Earth. NASA knew it was going to fall
Did it
back
crash?
down, but they didn't. They weren't able to control it, and it ended up burning up over the Western Australia, and parts of it landed on Esperance. So there's at the Esperance Museum there's bits of burnt up fuel tanks and bits of insulation and padding and things like that. There's a little part of the display at the museum. So yeah, if you haven't been, or if you're ever going to Esperance, go and check it out. I mean, there's not much left. It's very hard to survive re-entry, but
Yes.
it's part of Skylab. And the old joke that is 100% true that the Shire of Esperance sent NASA a fine for littering.
I mean, they did.
Yeah,
They dropped some of their litter on beautiful Esperance.
yeah, that's worth a fine in my opinion.
Brings us to our final segment,
Final
which is
segment.
our new segment.
Yeah, new
another new
segment.
segment, which is what's going on in the SciTech Planetarium.
Yeah. Meanwhile, in the SciTech Planetarium.
Meanwhile in the SciTech Planetarium.
And it might not be an every episode, just occasionally if there's
Well, we've
news
got
to talk
something
about.
fun going on.
Yeah, we got two things, and the first one I'm going to caveat by saying is not in the SciTech Planetarium.
No.
But we just have to mention it. Astrofest.
Astrofest.
So-
Astrofest. I think that's already someone else's theme song. Maybe we can't
Could
use
be.
that one.
So for those of you who don't know, Astrofest is a public astronomy event put on by Astronomy WA in cooperation with a lot of, basically everyone who has a foot in the astronomy game in Western Australia.
Which is quite a few people.
Quite a few people contributes to Astrofest, including SciTech, and definitely. So when I say meanwhile in the SciTech Planetarium, this is not my project at all.
No.
But it's a public astronomy event. It's held at Curtin Stadium on the 9th of November this year, which is a Saturday night. From about 6 p.m. till about 9:30 p.m.
Mm-hmm.
You just turn up. It's a free event, 100% designed for family and for those of the curious. You don't need to be an astronomy expert to go there and see it. You can talk to astronomers. You can you can see science shows. SciTech will be there doing science shows.
Yay.
There'll be lectures from actual researching astronomers. You can learn how telescopes work. You can look through telescopes.
Can I look at space though?
Yeah. I mean, if you ask nicely, maybe someone will point their telescope at the Tarantula Nebula for you.
Ooh,
Yes.
that would be very exciting.
There'll be people giving night sky tours, with laser pointers that actually shine those green lasers into the sky.
Oh, good.
Yeah, it's 100% worth going to. It's the biggest public astronomy event in Australia.
Awesome.
Mark your calendar, Saturday the 9th of November, starting from 5:30. Obviously, the sun will still be up at 5:30, so the nighttime stargazing will be a little bit later, but you can absolutely turn up from 5:30 till about 9:30 p.m. So don't miss it. It's going to be awesome. I'll be there. You'll be there. We'll all be there.
No, I won't be there.
You'll be in...
I'll be in Esperance.
You'll be in Esperance. Okay.
I might be at Skylab.
You might be at Skylab. The other thing that I thought was pretty cool, worth talking about, which is in the SciTech Planetarium, is we are closing down for a couple of days in the middle of November. In fact, all of SciTech is, but that's for unrelated reasons. But while we're there, we're actually going to be getting a visit from our off-site maintenance.
Ooh.
So, little known fact that we actually get our equipment, our software and our hardware from a company in the United States.
Right.
And as part of that, they will send out an engineer every now and then to come and, just like you get
Have a
your
look.
car looked at by a mechanic, we get our planetarium looked at by a planetarium engineer, so to speak. And that's just really interesting. There's a lot of stuff that goes on to keeping a planetarium working.
Yeah.
Because, when you come to the planetarium, your experience, as it should be, is to see the presenter and their sort of user interface where they control the planetarium from their computer. But
Well, one of the things that I always forget is incredible about the planetarium is that we are running off 2 projectors, but they are running off 4 computers, which are then working together via a 5th computer.
Yep,
And that's
another
just
one for the sound.
Yeah, and a different computer for that. So we've got 6 computers for just running shows.
Yep.
And that's not including the backup computers and the servers and all of that. So there's a lot going on.
Yes, and all of it's synchronized within a microsecond and things like that.
Yeah, otherwise you get tearing where one screen is doing one thing at one speed and the other screen is doing another thing at a different
Yeah.
speed, and Earth is in 2 different semicircles and it's splitting and it makes you feel a little bit sick.
Yeah, that's right. So yeah, all that sort of stuff, it just needs maintenance. So
Yeah.
yeah, while the rest of SciTech is closed for actual electrical work,
Yeah.
we're going to be doing some behind the scenes TLC for the planetarium.
Oh.
Realigning the projectors, cleaning out the computers, dusting them off, updating the software. Things
Literally
like that.
dusting them off?
I dusted them off last week, but
There you go.
we'll do it again. But I thought that was just really interesting because this stuff doesn't take care of itself.
No.
Everything needs love and maintenance.
Yeah, including you.
Oh, that's nice.
Yeah.
So do you, Beth.
Thank you,
Everyone
everyone.
deserves love.
Remember, maintain your planetarium.
I think that's a perfect place to end it. Well, it's been a time and a half. Thanks for being here, Beth.
Thank you, Leon.
And thank you for listening. We'll see you next month where we talk about the night sky and the space news in the month of December. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.
And, excuse me. Losing my voice and adding all sorts of extra sounds today. So